Okay. Hello everybody. This is part 1.3 an exit model questions for chemical engineering thermodynamics by Lata Deso. It says first question says Joule-Thomson coefficient is defined as A Joule-Thomson coefficient, which is equal to the partial differentiation of pressure to partial differentiation of temperature at constant enthalpy. B partial differentiation of T with P at constant enthalpy. C partial differentiation of energy or internal energy with respect to temperature at constant enthalpy. D partial differentiation of energy or internal energy with respect to pressure at constant enthalpy. So before proceeding to or providing the answers for this question, let us explain what Joule-Thomson coefficient is. The Joule-Thomson coefficient is explained under first law of thermodynamics. Actually, the first law of thermodynamics deals with the conservation of energy. The Joule-Thomson coefficient is the ratio of temperature. It indicates the ratio of temperature decrease to the pressure drop. This coefficient is expressed in terms of the thermal expansion coefficient and the heat capacity. It is a function of both thermal expansion coefficient, which means that beta, and the heat capacity or Cp. In other terms, the Joule-Thomson coefficient is known as the Joule-Kelvin coefficient. Which means that another terms which explains the Joule-Thomson coefficient. The Joule-Thomson coefficient explains the change in temperature that accompanies expansion of a gas without production of work or transfer of heat. Additionally, the Joule-Thomson coefficient shows the temperature changes with pressure in an experiment in which the enthalpy is constant. So in this system, when the temperature changes with pressure, the enthalpy is constant. Mathematically, the Joule-Thomson coefficient is given as mu, which is equal to partial of temperature with respect to P at constant enthalpy. So depending on this explanation, the correct answer for this question is B, which indicates the mu, which means the Joule-Thomson coefficient, which is directly related with what we call it the partial of T with respect to P at constant enthalpy, which is explained in multiple choice B. The second question says a system in which there is exchange of energy but not of mass is called A or N-dash system. A isolated system, B open system, C insulated system, D closed system. So to offer or provide answers for this question, let us explain what are the systems. What are the thermodynamic system? Let us explain the thermodynamic system. The thermodynamic systems such as a system, boundary, and the surrounding are explained in this section. So a system is a finite quantity of matter or a prescribed region of a space, which means that a space that is used for a study or the space utilized for the study is considered as a system. The boundary is a line that separates the surroundings from the system. So it is called as the actual or hypothetical envelope enclosing the system. Surrounding is the area outside of the system. The area outside of the system which can be separated by the boundary. So in addition to this, the system can be in thermodynamics. The system can be classified into three: closed system, open system, and insulated systems. Closed system is the system that can exchange energy with the surrounding. There is an exchange of energy with the surrounding, but which cannot transfer mass or matter across the boundaries are considered as a closed system. So a system is said to be a closed system when there is an exchange of energy to the surrounding or with the surrounding, but which cannot transfer matter or what we call it mass across the boundaries is considered as a closed system. The second one is open system. Is a system that can exchange both energy and the matter, which means that this one is matter or what we call it mass with the environment or with the surrounding is considered as an open system. An open system, there are different systems that can utilize or that can use an open system, which means that which can exchange energy as well as mass. The third one is isolated system, which means that neither of the two, it didn't consider the open system or it didn't consider the closed system. So in isolated system, neither energy nor matter or mass cannot be crossed or exchanged with the boundaries. This is considered as an isolated system. So a closed system is thermally isolated when the enclosing walls are impervious to, when the enclosing systems are what? Insulated, or when they didn't transfer heat, they are considered as thermally isolated. A closed system is mechanically isolated when they are enclosed by rigid walls or rigid bodies. They are considered as mechanically isolated. So depending on this explanation, the correct answer for this question is D, which is closed system, which cannot exchange mass, but it can exchange energy. The energy is the only exchange in closed system. The third question, which of the following represents the viral equation of the states? A, this one is directly focused on the thermodynamic equations of states. So it says, which one of the following is the viral equation of the state? A, it says temperature is equal to RT divided by V minus B minus A over the square root of T times V in bracket V plus B. B, PV over RT, which is equal to 1 plus P over V plus C over V squared plus with the continuous C, which is equal to C P plus A over V squared in bracket V minus B, which is equal to RT. D, it says this one is the Duhem's equation, N1 U2 plus mu1 mu2, which is equal to A. So let us explain the different types of thermodynamic relations or thermodynamic equations, such as van der Waals equations, Redlich-Hong equation, Redlich-Hong equation, Penge-Robinson equation, and the viral equations. So let us see their equations, which means that their numerical equations. Van der Waals proposed the following equation to explain the pressure, volume, and the temperature behavior of the real gases. Those are the thermodynamic equations, which means that equation of status for real gases. So the van der Waals equations can be written as, or mathematically it can be written as P pressure plus A over V squared, closing the bracket, in bracket V minus B, which is equal to RT, where A and B are called van der Waals constants. So by relating pressure, volume, and temperature, we can develop the van der Waals equation. So the van der Waals equation is just written like this one, which means that on the statement, the multiple choice C is known as van der Waals equation. It shows van der Waals equation. The third, this equation, which means that the van der Waals equation is cubic in volume and below the critical temperature, and it has 3 real roots. for the pressure, volume, and the temperature. The largest is the vapor volume, the smallest is the liquid volume. When P is the saturation pressure, the smallest and the largest, which corresponds to molar volumes of the saturated liquid and the saturated vapor respectively. So from this we can understand that since the van der Waals equation contains cubic in volume and that is below the critical temperature, three real roots are analyzed. The largest for the vapor volume, the smallest for the liquid volume, and the addition of the two. The vapor volume for the largest component plus the smallest volume for the largest volume divided by 2, we can get what we call the mid value, which is the third real roots. The second one is Redlich-Hong equation. The Redlich-Hong equation is a two-parameter equation of state widely used in engineering calculations. Pressure, which is equals to RT divided by V minus B minus A over the root of actually T V bracket V plus B, where both A and B are considered as a constants. Where A and B are considered as a constants. So according to this equation A, actually equation A shows what we call as Redlich-Hong equation. Redlich-Hong equation. The other one is the third one is what we call it the Redlich-Hong solve equation. The solve proposed a modification to the Redlich-Hong equation, which means that the modification of the Redlich-Hong equation gives us the Redlich-Hong solve equation, which means that the equation that is derived by what we call it modifications. So pressure, which is equal to RT divided by V minus B minus A prime T divided by V in bracket V plus P is a Redlich-Hong solve equation, which is known as it is a thermodynamic equation of states. This is a thermodynamic equation of state, what we call it the Redlich-Hong solve equation. The third one is Penge-Robinson equation. The Penge-Robinson equation, actually in Aspen Plus, we can use the Penge-Robinson equation. When we are just selecting the models, we can select the Penge-Robinson model. So Penge-Robinson developed an equation that relates the state functions like pressure, temperature, and the volume. So the mathematical equation is written as follows. Pressure, which is equals to RT divided by volume minus B is a constant, minus A alpha divided by A times alpha divided by V in bracket V plus B plus B in bracket V minus P. This is called as the Penge-Robinson equation, where A, B are constants and alpha is written as a function of the reduced temperature and the eccentric factor. So this is a Penge-Robinson equation. So the last one is the Virial equation. The Virial equation expresses the compressibility factor, which means that the compressibility factor is the ratio of the actual volume or what we call the real gas to the ideal gas is considered as the compressibility factor. So the Virial equations express the compressibility factor of a gas or a vapor as a power series functions, which means that it is a power series expansion either in pressure or 1 over volume. So depending on this, Z, which is equals to PV divided by RT, which is equals to 1 plus B prime pressure plus C prime pressure squared plus D prime pressure cubed plus continuous, which means that since this one is a power series expansion, the equation continues. Or in other form, in the form of volume, we can write as PV divided by RT, which is equals to 1 plus P divided by volume plus C over V squared plus D over V cube continues. So depending on the above explanation, the variable equations, which means that which the question says which of the following equation indicates which one of the following is a variable equation of the state. So the correct answer or option for this answer is B, which is given as PV by RT is equals to 1 plus B divided by V plus C over V squared plus the continuous. So this is known as this equation represents the variable equation of the state, which is one of the thermodynamic equation of the state that shows what the power series in expansion form, either in pressure or in volume. Actually, this one is in the form of volume. The third, as similar to that of lecture 1.2, or what we call it, part 1.2, there is an important topic explanations which is helpful for your exit exam in thermodynamic, in chemical engineering thermodynamics exit exam. So this question directly focus, this topic explanation directly focuses on the difference between or the relation between or the pure substances, which means that the pure substance explanation for the PV diagram, which is saturated vapor or versus superheated vapor. So the dry or the saturated vapor, a vapor which has just complete evaporation. There is a complete evaporation, or complete evaporation is considered as the dry or what we call it saturated vapor. So here the pressure and the temperature of the vapor are considered as the saturation values, which means that here this point is considered as the saturated vapor, which means that at high temperature. Superheated vapor, a vapor whose temperature is greater than what we call it superheated vapor, is the temperature of the superheated vapor is greater than the saturated vapor. So a vapor whose temperature is greater than the saturation temperature corresponding to the pressure of the vapor is considered as superheated vapor. The other one is what is compressed liquid. The compressed liquid is a liquid whose temperature is lower than what we call it the saturation temperature, which means that the temperature of the compressed liquid is less than that of the saturated liquid. Saturated liquid, this is considered as the compressed liquid. Sometimes this compressed liquid is known as the subcooled liquid. The other one is saturated liquid, a liquid at the saturation temperature corresponding to the saturation pressure is considered as saturated liquid. A liquid at saturated pressure temperature at the given or corresponding to saturation pressure is considered as saturated liquid. Saturated liquid. The other important term is degree of superheat. The term used for the numerical amount by which the temperature of superheated vapor exceeds the saturation temperature. Superheat means the degree of temperature, or which means that the temperature of when the temperature of the superheated vapor exceeds the saturation temperature, which means that the saturated vapor, we can say that there is a degree of superheat. So in this explanation, the main difference between saturated vapor and the superheated vapor is that the temperature of the system for saturated vapor is minimum as compared with superheated vapor, but the temperature at superheated vapor is maximum. So the vapor whose temperature is greater than the saturation temperature is considered as superheated vapor. The vapor which has a complete evaporation, which means that the temperature of the saturated vapor is less as compared with superheated vapor. So as references you can use Engineering Thermodynamics written by Rajput and the textbook of Chemical Engineering Thermodynamics written by Narayanan. Thank you for your attention.